In a previous video, I showed how to manage the internal loads in Revit for early energy modeling using Autodesk Insight or systems analysis. In this video, I'm going to show you how you can very accurately develop and manage the envelope settings for the building. So I have this sample model just to show a few interesting things along the way. We have a regular Revit elements model with a curtain wall and a couple of window families. And then we have a massing element that mimics that building elements model to a large degree, except for the punched openings or the window families can't exist. However, you'll see that these curtain walls, being coplanar with the mass element, are going to produce a model nearly identical to the building element model. And then finally, there's a wall just sort of floating here out in space. And so this will be just a comparison of what happens when we create the energy model and look at the thermal properties of the elements that are created for the energy analysis model. And one more final thing is there's actually a basement in both of these buildings. So when we talk about developing the envelope settings, the first place we look at is on the Analyze tab. We'll go into the Energy Settings dialog. And under Advanced Other Options, and so in the Advanced Energy Settings dialog, if we scroll down, there's a section here at the end called Material Thermal Properties. And the naming is a little confusing, and this used to work a little different in the past, but for the past several years now, this is a hierarchical situation. So detailed elements is not checked, meaning that's not going to take effect ever in this current scenario. And then schematic types is not checked for any overrides. So none of this is going to take effect in this current scenario. So right now when we create an energy analysis model, the only thing that's looked at is this conceptual types option. And at this point in the game, it's just early comparisons of massing elements is the idea. So there's basically high mass and low mass options. And within each of those categories, there's highly insulated, cold climate, mild climate, low insulation, and no insulation. So those same settings for both a high mass construction and a low mass. So masonry, concrete versus wood, metal stud. And so if we go ahead and just create an energy analysis model right now, this is just a brand new file I just created these elements, so nothing else is different in this model than what you'd see in a normal out-of-the-box Revit model. So you can see we have our analytical spaces, one per floor, and I believe the width of this is 28 feet, so that's why there's no thermal zone. You can't get two 15-foot perimeter zones out of a 28-foot deep building. And then the other thing I always like to do so that we can look at the envelope is duplicate this analytical spaces 3D view that automatically was just created when we created the energy analysis model. And I'm going to rename it to analytical surfaces. I wish this would just get created automatically. Maybe someday it will. And then I'm going to adjust the settings for this particular view. I actually don't particularly like to see the building model grayed out, so I usually turn that off. So analytical surfaces. Notice it's set to filter for architecture. That's why I only see these two, spaces and surfaces. So now in this view, we can see some interesting things before we really get into the specifics of the envelope. Is I can see for my mass, so this was just a simple rectangular mass element that was extruded. This is an exterior wall, so if you look at the properties for this thing I just selected, Its surface type under energy analysis is exterior wall, and it has an R13 wood frame wall type. If I select the Revit Elements model, it's the exact same thing. So it doesn't matter if it's a Revit wall or a Revit mass element, the vertical thing, the surface, becomes an exterior wall. For the building itself, by the way, I don't have any Revit room or space elements placed. Revit's voxel algorithm that's used to create the energy analysis model, it automatically determines what's an exterior wall, what's a slab on grade, what's an interior floor, what's a below grade floor. And to that point then, we'll look at this a little further. Back here in the energy settings real quick, take a note that the ground plane is set to level 1. So although this was a single Revit wall, if we go back to the 3D model, single Revit wall that went from, let's call it top of footing, up the basement, up the first floor, and then 3 feet up to create a parapet above the roof. That same wall got split up into 3 separate walls. So the parapet, which actually has no effect for all practical purposes on the energy model, it might affect a tiny bit of solar heat gain, but not really in this particular scenario. So this parapet became a shade surface, and it has basically no thermal properties associated with it, as compared to the exterior wall, which is actually the most impactful between the conditioned interior space and the exterior. We see that there's an heat transfer coefficient, thermal resistance, and thermal mass value for that one element. We go down to the next part of this same wall, and we'll see that there is a underground wall that also has thermal properties, but they're different than the exterior wall. And then there's a little bit of shade surface even below that because the wall continued below the floor slab. So this particular piece of wall isn't adjacent to an interior conditioned space, so it just becomes a shade surface. And then finally, this isolated wall that is not adjacent to any interior conditioned space also becomes just a simple shade surface. So if there was an existing building next to your building, you could model that and have that be a shade surface that would affect the solar heat gain of your building. And then we'll also see for our curtain wall and our punched windows, we have some window properties listed here. So there's a specific type of window that's listed. So that's true for the Revit Elements model, and then that's also true for our massing model. You can see it's the same exact settings. And then finally, if we're talking about the envelope, we have the walls, the windows, and the roof. So you can see the roof in this particular case is R20 over roof deck. That's the Revit element roof. And then the Revit massing element has the same exact settings. So as you can see, you can get really good, close to a detailed Revit model results just by creating a Revit mass element and then associating mass floors with that to indicate that it's a conditioned space. And then if we go back to our energy settings dialog and look at conceptual types, everything we just saw is based on the settings in this dialog box. So if I were to change anything here and recreate the energy model, so I have to delete and recreate it for those changes to get embodied into the energy analysis model, the surfaces would be updated. Now the next thing, and actually just for a minute, let's remember that the roof is R20 and the exterior wall is R13. So I'm going to change the wall, but I'll leave the roof. So in this hierarchy here. Conceptual types is the default, and then schematic types is something we can override. So exterior walls, and there's actually quite a list here that you can pick from. So you could type the word brick, and every wall type that has the word brick in it will show up. If you're looking at the ASHRAE 90.1 minimum requirements for your particular climate zone, you might see something like R13 plus R3.8 continuous or R7.5 continuous insulation. That same nomenclature is captured here in these options, which is really great. And then there's a whole host of other wall types, and there's a PDF on my blog and on Autodesk's help website that lists all the specific layers of one of these. You'll notice that these only list the R value, or in this case the U value. They don't list the thermal mass, which is a really important component, so you need to make sure you pick the correct thing, because just picking two wall types that have different R values aren't necessarily going to produce the same results if they have a different element in them that has a substantially different thermal mass aspect to it. But we can type something like straw bale and see that there's a straw bale wall type. So I'm going to go back to R dash and pick something like R30 just to have a different number. So we'll see the exterior walls change, but the roof won't change because we didn't select override here. And now we'll delete the energy analysis model and then recreate it. And then it always brings you to the analytical spaces view. So I need to switch to my surfaces view. And we'll see that the roof didn't change, it's still R20. And then if we select a wall, you can see that the R value is R26. And so it's not R30 because this is actually a wood stud wall, and there's going to be thermal bridging based on the studs. So this is a properly derated R value, which is really great. And so that's already showing the hierarchy. Now that we have an override for exterior walls, all exterior walls are going to get that selected option. Now if I go back into the properties, I'll delete the energy model and recreate it in a minute. I didn't actually mean to delete it right there, but I did. So again, the exterior walls are being overridden with this R30 option, and then the conceptual types for exterior walls, this option's being ignored, but the roof option is still being used. Now there's a third option here using detailed elements. If I check that, now what's going to happen is if this exterior wall has thermal properties associated with it, so I go into the edit structure and we see that there is an R54 developed here based on each one of these materials having a thermal asset associated to it. So this metal stud layer actually probably has insulation in it in this particular wall type, and I have a blog post on my BIM chapters blog on how to properly develop a weighted thermal asset to take into account the studs and the insulation. So you can see there's the thermal conductivity, the specific heat, and the density. You'll typically see these three values if you go to a insulation manufacturer's website and download a product data sheet. And you can plug in these values, and then when you adjust the thickness of that insulation material, the R value should change and equal what that cut sheet says. Each thickness of that manufacturer's insulation is this particular R value. And to test that, you could delete all of these rows and just try it with one one layer. So anyways, this has a R50 associated with it. So we should see that come through when we recreate the energy analysis model. One thing though to note is if I go to the roof and go to edit type, edit structure, this doesn't have an R value. So in this scenario, it's going to default back to the previous thing, and since we didn't have an override for schematic types, it'll go back to all the way back to conceptual types. So let's give that a try. I'm going to create the energy analysis model. Go to my analytical surfaces, and now when I pick the wall, this is R54. So in this case, if we needed to derate this, we would have to have done it in the thermal assets for each layer in material. So that number that you see in the edit structure dialog is the same exact number that's going to come through. Same with the thermal mass value, which is great. Once you understand how it works, it's really easy. And for our mass, since it's not a Revit element, this particular mass is still using the override value. So this is not a Revit element, and checking that box then has no effect, of course, on a mass. And then the roof, even though there was a roof element that had properties associated to it, this is still just the R20 wall type. You can see the roof and the mass elements are the same. So that's the high-level overview of this. If detailed elements is checked and there's Revit elements, and those Revit elements have thermal assets associated with that material, then the detailed elements thermal properties will be applied to the surface. If there is a detailed element and there's not thermal assets associated with it, it'll fall back to any schematic type overrides. And so if there's an override, it's going to use this and stop there. If, for example, the roof doesn't have an override, then it's going to default back to whatever the mass roof setting is. This is confusing because it says mass roof and it also applies to detailed elements, but nevertheless, that's how it works. One last thing that's interesting to note for detailed elements is a little trick I've used. If I want to make sure there's a couple of wall types that need to have different R values, so you have to use detailed elements. If there's different parts of an exterior wall that need to have different thermal resistance and thermal mass values, you can check detailed elements, but then if you want to make sure that, for example, if there is a roof so this particular roof doesn't have an R value, but there may be some other roof elements like this one, for example, that does have an R value. So if we were using this roof but didn't want this R value to actually be included in the energy analysis model, and if we had detailed items checked in the energy analysis dialog, because we want the walls to be used, we can actually manipulate this. If we're not using it for energy modeling, we probably don't need this R value for anything. So we could go into the materials and actually delete the thermal asset for every material in this particular roof. Of course, if this particular insulation that I just deleted was used in the wall, that would have messed up my wall. But if you understand how this works, you can duplicate the asset or the material and make sure that what's used for the walls are not being affected. So now this is R0 and thermal mass 0. So when I create the energy analysis model, since this has no thermal properties, it will default back to that the schematic type, and if there's no schematic type override, it'll go back to the conceptual type. So that's a bit of a long-winded overview, but super helpful, I think, in developing an accurate energy analysis model for use in Insight or Revit systems analysis.